Hello, dear ladies and gentlemen and professor. My name is Shokrat Beg, and we are here in Advanced Computer Architecture 2024 Fall. And today, Project 2 Research Presentation 1. And my topic is about Aragorn, a privacy enhancing system for mobile cameras. So, today I would like to clarify about the Aragorn project. So, let's jump into the topic. First of all, about today's presentation. I'm going to clarify you about an introduction to privacy challenges in mobile cameras, the architecture of Aragorn, how the functionalities and performing of the Aragorn field, and also the future directions and conclusions. So, mobile cameras enhance app functionality but pose significant privacy risks by capturing sensitive information. Unrestricted access to camera's frame can lead to unauthorized data exposure, necessitating effective privacy controls. The architecture of Aragorn is designed to provide fine-grained control over camera access by automatically sanitizing frames. It operates independently of hardware and app frameworks, ensuring robust privacy protection while maintaining app utility. About the functionality and performance of Aragorn effectively detects and obscures non-essential regions in camera frames, achieving high accuracy in identifying sensitive objects. Its implementation incurs minimal performance overhead, ensuring a seamless user experience. But the future work may focus on enhancing support for uncommon objects and improving the sanitizer's accuracy. Overall, Aragorn represents a significant advancement in mobile camera privacy, balancing user privacy with app functionality. So, about the privacy challenge mobile cameras. There are some privacy risks. Mobile camera can capture sensitive information from the user's environment, leading to potential privacy violations. And limited control. Users currently have only coarse-grained control over which apps can access the camera, lacking the ability to manage what specific data is captured. Third, inadvertent exposure. Camera apps may unintentionally record sensitive objects or background details which can be exploited for tracking or profiling users. Last but not least, user distrust. Surveys indicate a general distrust among users regarding camera access, highlighting the need for improved privacy measures. An overview of mobile camera usage and privacy risks. So, widespread use. Mobile cameras are commonly used in various applications, including social media, banking, and augmented reality (AR), enhancing user experience and functionality. Data capture. Those cameras can capture rich visual information which may include sensitive personal data, leading to privacy concerns. Privacy risks. Apps may misuse camera access to collect identifying information or track users without content, raising significant privacy issues. User awareness. Many users are unaware of the extent to which their camera data can be exploited, emphasizing the need for better privacy control and detection. There are some current limitations in camera app privacy control. So, let's talk about pros. So, as you see, there are two pros: basic access control and user awareness. What does it mean? Basic access control means user can limit which apps access their camera, providing a foundational level of privacy. User awareness. The discussion around privacy risks encourages users to be more cautious about app permissions. And on the other side of the coin is there are some cons. So as you see, there are three. First is about coarse control. Users lack fine-grained control over what specific information within camera frames can be accessed, risking exposure of sensitive data. Second, inadvertent data capture. Camera apps may unintentionally capture sensitive background information, leading to potential privacy violations. Third, cognitive burden. Privacy solutions often require significant user effort and attention, making them impractical for many users. So, privacy. Need for fine-grained privacy solutions. First, the importance of tailored privacy, user-specific needs. Different users have varying privacy requirements based on their context, preferences, and the sensitivity of the information being captured. Tailored privacy solutions allow users to customize settings according to their individual needs. The second one is contextual awareness. Fine-grained privacy controls can adapt to different scenarios, ensuring that only relevant information is shared while protecting sensitive data. This adaptability enhances user trust and comfort with mobile applications. The third one is minimizing data exposure. By implementing tailored privacy measures, users can limit the exposure of sensitive information, reducing the risk of unauthorized access and misuse by apps. This is crucial in maintaining user privacy in an increasingly data-driven world. So let's have some introduction to Aragorn as a solution. So the first is about overview of Aragorn's purpose. The overview is about a privacy protection. Aragorn aims to safeguard user privacy by controlling what camera data is accessible to apps, ensuring that only relevant objects of interest area processed. User empowerment. It allows users to define and manage their privacy preferences, giving them greater control over their personal information. Seamless integration. Designed to work within the mobile operating system, Aragorn enhances privacy without disrupting the functionality of existing camera applications. And about the key features of Aragorn. The key features of Aragorn is about automatic sanitization. Aragorn automatically detects and obscures background information in camera frames, focusing solely on user-specified objects of interest. Customizable preferences. Users can easily customize their privacy settings by selecting which objects to prioritize, with the option to overwrite app defaults. Federated learning. The system employs a federated approach to improve its object recognition capabilities, while maintaining user data confidentially, minimizing the risk of data exposure. The last one is minimal user burden. Users are required to provide minimal inputs, such as answering simple yes or no questions, to enhance the system's effectiveness without adding significant effort. So, architecture of Aragorn. Integrating with mobile OS. Aragorn operating within the mobile operating system. Intercepting camera frames before they reach camera apps. Ensuring privacy is maintained at the system level. Sanitizing components. The core of Aragorn is the sanitizer, a machine learning based object detector that identifies and retains only the specified objects of interest while obscuring all other information in the camera frames. Steady state and transit workflows. Aragorn functions in two workflows. The steady state workflow, where the sanitizer's reliability detects objects and the transit workflow, which allows for additional training when new objects are introduced. Aragorn server. An auxiliary to remote server supports the sanitizer by extending its capabilities to recognize previously unrecognized objects, enhancing the system's adaptability and effectiveness. So let's look at the overview of Aragorn's system design. So about the first one, system architecture overview. Modular design. Aragorn features a modular architecture that separates the sanitizer from camera apps, allowing for efficient processing of camera frames while maintaining privacy. Interception layer. The system intercepts camera frames at the operating system level, ensuring that only sanitized frames containing user-defined objects are accessible to apps. Machine learning integration. The sanitizer employs machine learning algorithms to detect and recognize objects of interest, continuously improving its accuracy through user interactions and feedbacks. The second one is privacy control mechanism. Automatic sanitization. Aragorn automatically obscures non-essential information in camera frames, focusing solely on user-specified objects to protect privacy. User customization. Users can define their privacy preferences by selecting objects of interest with the ability to override app defaults, ensuring tailored privacy settings. Data minimization. The system adheres to the principle of least privilege, limiting the data shared with apps to only what is necessary for functionality, thereby reducing potential privacy risks. Third one is user interaction framework. Permission dialogues. Upon first use, users are presented with a one-time permission dialog to grant access to specific objects of interest, facilitating informed consent. Feedback mechanism. Users can provide feedback on the sanitizer's performance, helping to refine its object detection capabilities and improve overall effectiveness. Intuitive interface. The user interface is designed to be user-friendly, allowing for easy customization of privacy settings without requiring extensive technical knowledge. So let's look at about the key components of the Aragorn framework. Real-time object detection. Machine learning algorithms. Aragorn utilizes advanced machine learning techniques to perform real-time object detection, identifying user-specific objects within camera frame. High accuracy. The system achieves high accuracy rates such as 89% for credit card detection and 100% for face recognition, ensuring effective sanitization without compromising functionality. Continuous learning. The object detection model is continuously refined through user interactions and feedback, enhancing its ability to recognize new announced objects over time. The second one is user-centric privacy control. Customizable performance. User can easily specify their objects of interest, allowing for tailored privacy settings that align with individual needs and contexts. Override capabilities. Users have the option to override app-specified objects, ensuring they maintain control over what information is shared and processed. The third one is seamless integration. Operating system level. Aragorn is integrated at the operating system level, intercepting camera frames before they reach apps, which allows for a smooth user experience without requiring change to existing applications. Compatibility with drives apps. The framework is designed to work with a wide range of camera applications, providing robust privacy protection across different use cases. Low privacy overhead. The implementation incurs minimal performance overhead, maintaining a high frame rate and ensuring that app functionality is not degraded during use. So let's have a look to the workflow of the sanitizer in camera frames. So the first one is real-time frame analysis. Frame interception. The sanitizer intercepts camera frame in real time as they capture, ensuring immediate processing before any app can access the data. So object detection. Utilizing YOLO version 3, the sanitizer analyzes each frame to identify and classify objects, focusing on those specified by the user as objects of interest. So the second one is dynamic obfuscating techniques. Selective obfuscating. Based on the analysis, the sanitizer retains only the identified objects of interest while dynamically obscuring all other elements in the frame to protect user privacy. So adaptive processing, the obfuscating techniques adapt to the context of the frame, ensuring that sensitive information is effectively hidden without compromising the visibility of the relevant objects. The third one is user feedback integration. Feedback collection. After processing, users are prompted to provide feedback on the sanitizer's predictions, indicating whether the highlighted regions accurately represents the object of interest. Continuous improvement. User responses are used to refine the sanitizer's object detection capabilities, allowing it to learn from mistakes and improve accuracy over time. So let's look at about the integration with mobile operating systems. So the first one is seamless operating system compatibility. Native integration. Aragorn is designed to integrate natively with mobile operating systems, allowing it to function without requiring significant modification to existing camera applications. Process isolation. By operating in a separate process from camera apps, Aragorn ensures that the sanitizer can effectively manage privacy without interference from app level operation. The second one is API utilization for functionality. Camera API access. Aragorn leverage existing camera APIs provided by the operating system to intercept and process camera frames efficiently. Jetpack libraries. The system can utilize Android Jetpack libraries such as Camera X to enhance its functionality and streamline integration with modern app development. The third one is user experience enhancement. Minimal disruption. The integration is designed to be unobtrusive, allowing users to continue using their camera apps as usual, allowing users to continue using their cameras apps as usual while benefiting from enhanced privacy protection. Real-time feedback. Users receive immediate feedback on the sanitizer's performance, fostering a sense of control and trust in the system's ability to protect their privacy. So let's look at about the functionality and performance of Aragorn. Real-time object detection. Aragorn provides real-time of user-specified objects within frame cameras, ensuring that only relevant information is processed while obscuring background elements to protect privacy. So, object detection and privacy. Object detection and privacy preservation mechanism. Real-time object detection. Advanced algorithms. Aragorn employs state-of-the-art object detection algorithm such as YOLA version 3 to accurately identify and classify objects of interest in real time as camera frames are captured. And dynamic adaptation. The object detection mechanism dynamically adapts to various environments and contexts, allowing it to recognize a wide range of objects specified by the user, thus enhancing the overall privacy protection strategies. So let's look at about the evaluation of accuracy and utility in real-world scenarios. Assessment of real-world performance. So, field testing. Aragorn's performance is evaluated through extensive field testing across diverse environments, including indoor and outdoor settings, to ensure robust object detection and privacy preservation under varying conditions. Accuracy metrics. Sorry for the noise, my neighbors, they are having a bit of play. So the next one is accuracy metrics. The system demonstrates high classification accuracy, example 100% for credit cards, and maintaining localization accuracy around 80%, validating its effectiveness in real-world application. So let's look at about performance metrics: frame rated and battery consumption. The frame rate optimization, minimal impact on frame rate. Aragorn incurs an average drop of only 0.01 frame per second when processing camera frames, ensuring that real-time object is maintained for most camera applications. The second one is battery efficient strategies. Low power consumption. The implementation of Aragorn is designed to have a minimal impact on battery life, with an average increasing in battery consumption of only 0.06% during operation. The performance trade-offs. Balancing accuracy and speed. While Aragorn prioritizes real-time performance, there may be trade-offs in detection accuracy under certain conditions, necessitating ongoing adjustment to maintain optimal performance. So let's look at about user experience and minimal effort required. Intuitive interactions. Aragorn is designed to require minimal user interaction, primarily asking users simply yes or no questions regarding to the object of interest, which reduces cognitive load and enhances usability. Seamless integration. The system operates in the background without disrupting the normal use of camera applications, allowing users to engage with their devices naturally while benefiting from enhanced privacy protections. So let's look at about the future directions and how they're gonna end. And enhanced object recognition. The future development may focus on expanding the range of detectable objects and improving recognition accuracy in diverse and challenging environments, further enhancing privacy protections. So, broader application integration. The goal is to integrate Aragorn with a wider array of applications and devices, promoting widespread adoption and ensuring comprehensive privacy solutions across various mobile performances. So, in conclusion, Aragorn represents a significant advancement in privacy-enhancing technology for mobile cameras. balancing effective object detection with user-friendly experiences while paving while while connecting the way for future innovations in privacy preservation. So next one is, let's look at about the extensibility and support for new object recognition. Aragorn's extensibility and support for new object recognition are enabled through its centralized approach to training the sanitizer, allowing for the detection and blocking of previously unsupported objects with high accuracy. Additionally, users have the ability to contribute training data and override objects of interest, ensuring the system remains adaptable and user-friendly. So let's look at about mitigating data integration risks, addressing data poisoning and security concerns. Aragorn effectively mitigates data integrates risk by implementing primitive and reactive defense strategies to address data poisoning attacks. User validation helps detect and discard poisoned images, while the sanitizer can be retrained if compromised. This approach ensures the system's robustness against security concerns and maintains the integrity of the data processed by the system. So let's look at about some key contribution and impact on the privacy and enhanced user control. Aragorn's key contributions include enhanced user control over privacy settings for mobile camera apps by automatically sanitizing camera frames to detect essential regions, and blocking out irrelevant information. Users can have greater confidence in their privacy while retaining utility in their app usage. This level of control empowers users to protect their personal information and sensitive data from unauthorized access or misuse, ultimately enhancing their overall privacy and security in mobile camera environments. So this was the end and the topic. I was really enjoyed about the topic and having some kind of research and making the presentation. It was all the best. The Aragorn privacy, I haven't heard about that before. Now I see there might be some misuse of the privacy through the mobile cameras. So if you have further questions regarding to the project Aragorn or about the mobile cameras privacy, you can reach me out, and I'm glad to share some kind of ideas with you. And thank you for having me in your time. And feel free, if you have questions, feel free to reach me out. Thank you, and have a good one, everybody.